Hey there. Um, so I guess this is going to be like first of a series of videos about Unit 3. And if I look like I'm sort of staring off into space, sometimes I am. Other times I'm lecturing from notes because I want to make sure that I hit everything. So don't worry about it too much. The other thing is that I figured out I could do some effects, and so I kind of enjoyed the Beastie Boys effect of doing the fisheye. So that's what we're getting here, and I dig it for this video. I won't do it every time, but just for my long term, people watching the videos, I want to, have some interesting things in there other than the door behind me. Um, so the purpose of this video is to talk about some of the intermolecular forces. And I guess where you got to start with intermolecular forces are London dispersion forces. Okay, London dispersion forces are the weakest of the intermolecular forces we're going to talk about. Okay, and so when you think about dispersion forces, you have to unlearn some stuff. So the first thing that you have to unlearn is when you were in middle school, you did these little diagrams of atoms and they had rings on them and the electrons were all in the rings and they were being built out like that. Um, and so when you did those diagrams, it kind of made it look like the electrons were orbiting a nucleus, and that's just not how electrons like to behave. Electrons, they behave kind of randomly. Not kind of randomly, they do behave randomly. And so what it is they have enough energy to remain a certain distance away from the nucleus. And then sometimes they absorb energy and they can move farther away, but then eventually they'll come back. Sometimes they absorb enough energy and they just get ejected, like when we were talking about, mass spec. You got to knock all the electrons off. So you can put enough energy in there to knock the electrons off. But when you're talking about London dispersion forces, you have to realize that electrons are in certain regions around the nucleus. Those regions are, 1s2, there's usually 2 electrons there. 2s2, there's usually 2 electrons there. 2p6, 6, so on and so forth, ad infinitum till you fill it out. That's why we do electron configurations. And so these electrons are all sort of moving in those regions. An electron is never still, an electron is never orbiting either. It's just moving, randomly and very, very fast. We couldn't see an electron move even if it wasn't teeny tiny. But if you have something that's moving, and you have something that's moving randomly, and you consider the fact that it has a negative charge, you're going to eventually, just from the random movement, get the electrons moving close together into a region. And so it's just random, okay? So, just because of the random motion of the electrons, there gets to be a region of kind of high density. And if you have those charges gathered around that area, then you get a little brief negative charge, okay? And what that does is, for the atom next to it, it kind of chases away some electrons, making that a region instantaneously positive, okay? So all the electrons sort of gather up just really quickly in a space, randomly. There's nothing that causes it to happen. This is London dispersion forces. It just happens randomly. So you get the negative random. It causes a little random instantaneous positive because all the electrons kind of go, ew, I don't want to be around there because it's all, all electrons. And the like charges repel. And so you get a little instantaneous attraction, and it's there and then it's gone. and it doesn't last very long, and it's not very strong, but it does exist. And for some larger molecules, that's basically the only intermolecular force that's holding them together. And so that's why, um, you can uh, you can look at some of these larger molecules, and some of them get so large. We're talking about fats and stuff like that. These big carbon chains. Some of them get so big that they're solids at room temperature. Others get will become liquids. And then, the smaller ones are gases at room temperature. And that's because there's not really a whole lot holding them together under these, other than these London dispersion forces. So, to summarize, London dispersion force, weakest force. It occurs basically between nonpolar things, and it is just an instantaneous collection of electrons that chases electrons of another atom or region away. Then they're attracted, and then they repel. Because you got to remember, those electrons that cause the London dispersion force in the beginning, they aren't going to be there very long, because electrons are always moving and moving very quickly. Intermolecular force number one, London dispersion force.